us see electrical conductivity. It is defined as the amount of charges conducted per unit time across unit area of cross section per unit applied electric field. So sigma is equal to amount of charges, which can be represented as Q, divided by per unit time divided by T per unit area of cross section. So divided by A per applied electrical field, capital E. Sigma is the term, a symbol used to represent electrical conductivity. So sigma is equal to Q by TAE, amount of electrical charges conducted per unit time across unit area of cross section per unit electric field. We know that Q by TA, where Q by T is the current, is the definition of current, charge per time, charge per unit time, which is defined as the current I. The current divided by area is equal to current density J. Current density is defined as the current per unit area, amount of current per unit area. So J, sigma can be written as J by E, or J is equal to sigma E. It's another form of Ohm's law. So this is the equation of sigma is equal to Q by TAE is the equation of electrical conductivity. Now let us see its derivation. To derive the electrical conductivity derivation, let us consider a conductor. A conductor which contains the electron of charges E. In the absence of electrical field, all the electrons are moves in the random direction. When we apply the electric field E, these electrons are drifted towards the direction of the opposite to the positive terminal of the applied electric field, or opposite to the direction of the electric field. This is the direction of electrons and this is the direction of the electric field E. So when the electrons flows this direction, the current will flows in the direction opposite to the direction of electrons. Direction of current is opposite to the direction of the electrons. So what is the Lorentz force acting? Lorentz force acting on the electron is F is equal to charge of the electron into the applied electric field. Take it as equation 1. The Lorentz force acting on any charged particle is placed on a electric field. The force gained by the electron is called as the Lorentz force, which can be written as the product of the charge of electron and the applied electric field. So the Lorentz force acting on the electron due to the applied electric field is equal to E into E. And according to Newton's second law, the force F is written as mass into acceleration. Take it as equation 2. Comparing equation 1 and 2. From equation 1 and 2, this is from Newton's second law of motion. By comparing equation 1 and 2, we can write ma is equal to E into E. Both forces are equal and opposite. So A is equal to E divided by m. We know that acceleration A is equal to, acceleration is defined as the rate of change of velocity or velocity divided by time taken. So here the acceleration can be written as drift velocity divided by relaxation time. So A is equal to Vd is divided by time, tau, relaxation time, tau. So Vd is equal to, just to compare, take it as equation, this as equation 3, acceleration A as equal to E by m is taken as equation 3, and by definition we have written A as Vd by tau. This can be taken as equation number 4. Comparing these two equations 3 and 4, by comparing these two from 3 and 4, or substitute 4 in 3, Vd by tau is equal to E by m. Vd is by tau is equal to E by m. So Vd is equal to E by m into tau, or for convenience we can write it as Vd is equal to E tau by m into E. Take it as equation number 5. What is the relation between the current density and drift velocity? Then we know that the symbol for current density is J and drift velocity Vd, which is the velocity acquired by the electron due to the applied electrical field. So J is equal to the relation between drift velocity and current density. J is equal to N E V suffix D, that is the drift velocity. Equation number 6. Substitute equation 5 in equation 6. This has to be substituted here. Just to convert, bring it here. Substitute Vd, substitute 5 to equation 6. So J is equal to N E Vd, replace Vd as E tau by m into E. So J is equal to N E square tau by m into E. We know that the definition, or from Ohm's law, J is See this, J is written as sigma E. From that we can write J is equal, take it as equation 7. This can be written as equation 7, where J is equal to sigma E. Take it as equation 8. This we are taken from the definition, or we can, it is a Ohm's law. Compare equation 7 and equation 8. By comparing these two, sigma is equal to, left hand side are equal, E are same, so the balance term sigma can be written as n e square tau by m, or we can substitute and equate like this one, sigma E is equal to n e square tau by m into E getting cancelled, sigma is equal to n e square tau by m. This is the equation of electrical conductivity. By knowing the number of electrons, charge of electrons and mass of the electrons, all these are all constant. So by knowing the value of the relaxation time, we can measure the electrical conductivity. Thank you.